Hello YouTube. Today I want to talk about the use of chemical weapons in antiquity. And I gotta tell you, no aliens gave these weapons to our ancestors. Humans are very keen when it comes to making warfare and making weapons and improve such weapons century after century and get involved in all kinds of military conflicts. And some of us are very ingenious too when it comes to creation of unusual types of weapons. So when we talk about the use of chemical weapons, terrible pictures of the battles of the First World War blinded and suffocated soldiers. Also, the Red Army in the Soviet Union using gas against Russian peasants who did not want socialism and forced collectivization. Also, pictures of the concentration camps of Nazi Germany and recent incidents during the civil war in Syria. That's what immediately comes to mind when you speak about chemical weapons. However, chemical weapons were known back in the time of the Greeks and Romans, and they were actively using such during the ancient wars. So here is an interesting story. And then the princess put on a dress, a gift from the sorceress Medea, and spun in front of the mirror. Suddenly the dress caught fire with a bright flame. The girl tried to tear it off the flaming cloth, but the fabric stuck to the skin, and the hot fire broke out with renewed vigor. The princess, engulfed by waves of devouring fire, jumped out of her bedchamber and rushed into the fountain, but the water only inflamed the flame more. The girl's father, King Creon, tried to put out the fire, but caught this fire himself. They died together, burned alive. The flames spread, destroying the entire palace and everyone inside. This is the scene from the Euripides' Medea, based on an ancient Greek myth, and it was performed in Athens in 431 BC. It describes a terrible fire weapon invented by Medea from Colchis, who helped her beloved Jason and his Argonauts find the golden fleece. When Jason left Medea, she took revenge on his new passion, the Corinthian princess Glauca. The sorceress treated a beautiful dress with secret substances that stored the power of fire, sealed the gift in an airtight casket, and handed it to the unsuspecting princess. How did Medea manage to create such a dress? The popularity of this story in Greek and Roman literature and art suggests that some real but unusual phenomenon associated with fire inspired its storytellers to create a legend. The idea that things can suddenly ignite due to water or under the influence of heat must have looked plausible to an audience back in the 5th century BC. Some thinkers, such as Diodorus Siculus, believed that Medea knew about a certain magical substance that, once set on fire, could not be extinguished. According to Euripides, Medea combined special volatile substances that were isolated from air, light, moisture, and heat up to a certain point. The resulting burning led to the appearance of a flame. It was sticky, slow burning, extremely hot, and unquenchable with water, very similar to modern napalm. The myth points to the knowledge of chemical weapons more than 1,000 years before the invention of Greek fire in the 17th century AD. Fire itself has always been a weapon since the moment when an angry humanoid or hominid grabbed a burning log from the fire and threw it at the cause of his anger. The Roman philosopher Lucretius wrote that fire became a weapon as soon as people learned to make bonfires. In the Greek myth, Hercules used burning arrows and torches to destroy the monster Hydra. Flaming arrows served as a weapon of heroes of the great ancient Indian epics Mahabharata and Ramayana. Fire arrows were a fairly early invention in human history, and Assyrian reliefs images of the 9th century BC show attackers and defenders exchanging volleys of burning arrows and fire pots, obviously filled with oil, over fortified walls. In ancient India, fire weapons were common enough to become banned in the laws of Manu. The oldest collection of law forbade kings to use weapons incandescent with fire or covered with burning materials, although Kautilya's Raja Shastra and several other Indian treatises of the same era give many recipes for creating chemical fire projectiles and smoke weapons. Meanwhile, in China, during the feudal conflicts between the warring kingdoms, I would say from 403 to 221 BC, Sun Tzu's The Art of War and other military treatises promoted the use of fire and smoke to intimidate enemies. The first incendiary projectiles were arrows wrapped with highly flammable vegetable fibers, flax, hemp, or straw. Burning arrows have become an effective weapon when destroying wooden walls from a safe distance. For example, during the capture of Athens by the Persians in 480 BC, burning hemp arrows were actively used. By that time, Xerxes had already destroyed many Greek cities with fire. But simple flaming sticks with straw were not destructive and deadly enough to satisfy the ancient strategists. Burning arrows are of little use against stone walls, and bonfires derived from them can easily be distinguished with water. Human beings needed something that would actively burn and could not be extinguished with water. What chemical additives can cause a fire strong enough to burn down walls, take over cities, and destroy enemies? The first additive was a plant chemical, resin extracted from pine. Later, the distillation of resin into raw turpentine became available. The resinous fire was actively burning, and the sticky juice resisted the water. The earliest evidence that the Greek army used fire arrows is in the Thucydides' history of the Peloponnesian War. In 429 BC, the Spartans besieged the city of Plataea, an ally of Athens, and used a full arsenal of siege techniques against the stubborn inhabitants of the city. The Spartans used fire arrows so that the Plataeans defended their wooden palisades with untreated animal skins. In the future, many besieged cities will use similar tactics. The Plataeans then attacked and disabled the Spartans' siege engines. Therefore, the Spartans had to move beyond the usual flaming arrows into the still unexplored world of chemical fuel. This event took place just 2 years after Euripides' play about the mysterious recipe for that strange fire of Medea. The Spartans piled up a huge pile of brushwood right at the city wall. Then they added a large amount of pine sap and used sulfur as a bold innovation. Sulfur is a chemical element found in pungent-smelling yellow, green, and white mineral deposits in volcanic areas, around hot springs, as well as in limestone and gypsum matrix. People have long noticed that when volcanoes erupted, fiery rivers and lakes of burning sulfur disappeared. In ancient times, sulfur was actively used, from medicines and pesticides to bleaching. The flammable nature of sulfur also made it an extremely attractive incendiary substance. When the Spartans set fire to the walls of the platea with resin and sulfur. This action produced a fire, as has never been seen before. The blue sulfur flame and the acrid stench must have made an amazing impression on contemporaries, since the burning of sulfur creates a toxic sulfur dioxide gas, which can lead to death if inhaled in sufficiently large quantities. Many of the walls of the city were destroyed, but then the wind changed and the fire eventually subsided after a severe thunderstorm. Plataea was saved, as it seemed then, by divine intervention into the technological innovations of the Spartans. Notably, this is also the earliest recorded use of a chemically enhanced incendiary substance that created a poisonous gas, although it is not clear if the Spartans were aware of this deadly side effect when they threw sulfur into the flames. The defenders quickly learned to use chemical fires against the besiegers. Written around 360 BC, the book of Ennius Tactica, telling about how to survive a siege, devoted a section to fire supplemented with chemicals. He recommended pouring resin on enemy soldiers or on their siege engines, and then using bundles of hemp and pieces of sulfur, which were supposed to stick to the resin, and then ignite the resin and sulfur. Okay? So Aeneas also described a kind of spiked bomb filled with flaming material that could be dropped on siege engines. Iron spikes stuck into the frame of the siege engine and its wooden base burned. During the grueling year-long siege of the island of Rhodes by Demetrius Poliorcetes in 304 BC, both sides threw tarred shells at each other, fire parts and flaming arrows. In one night, the Rhodians fired more than 800 fire shells of various sizes. Rhodes' resistance was successful, and Poliorcetes retreated, tarnishing his own reputation by abandoning his siege equipment. By selling his machines, the Rhodians financed the construction of the Colossus of Rhodes, one of the 7 wonders of the ancient world. To protect Aquileia, northeastern Italy, when this city managed to withstand the long siege of Emperor Maximinus in 236 AD, catapult pots with sulfur and bitumen were used. Later, incendiary mixtures were packed inside hollow wooden barrels of bolts for catapults and scorpions. Vegetius, late 14th, early 15th century AD, military engineer, in his treatise gives a recipe for ammunition: sulfur, resin, tar, and hemp soaked in oil. Ammianus Marcellinus, 4th century AD, described fire arrows fired from bows. The hollow reed shafts were elaborately reinforced with iron, and many small holes were made in them on the underside to provide oxygen for burning. The boom cavity was filled with bitumen materials. In ancient times, various petroleum products were called bitumen. Arrows flashed when they came into contact with water, and it was possible to extinguish the flame only by covering it with sand. The fire dart, described by Marcellinus, is similar to the Chinese fire spear, invented around 900 AD. It is a bamboo, later metal, tube made with a single hole filled with sulfur, charcoal, and a small amount of explosive saltpeter or nitrate salts, the key ingredient of gunpowder. The tube was attached to a spear with something like a pump, so a kind of flamethrower was obtained. In one of the naval battles during the Second Punic War, the Roman commander Gnaeus Scipio made prototypes of Molotov cocktails by lighting shells filled with resin and oil and throwing them on the wooden decks of the Carthaginian ships. However, wooden ships were not only good targets, but their flammability also made ships attractive fire delivery systems. For example, during the ill-fated Athenian attack on Sicily in 413 BC, the Syracusans came up with a creative use of fire in a naval battle. They loaded an old merchant ship with pine twigs, set it on fire, and simply let the wind carry the fire ship to the Athenian flotilla of wooden triremes, name of the ships. The soldiers of Alexander the Great faced another terrible weapon in 332 BC during the famous siege of Tyre. It was an island city on the coast of Lebanon. Phoenician engineers invented an ingenious and terrible torture that even the strongest warriors could not endure. They filled shallow iron or bronze bowls with fine sand and metal shavings. Then they heated these pans on fire until the sand was red hot, and with the help of a catapult, they sent the burning sand to the Macedonians. This red-hot shrapnel fell under the breastplates of soldiers and left terrible wounds on the skin, causing insane pain. Alexander's men wriggled, trying to take off their armor and shake out the burning sand. The rain of burning sand in Tyre, created more than 2 millennia ago, bears a striking resemblance to the effects of modern metal incendiary substances, such as magnesium or thermite mixtures. Burning materials often produce poisonous, suffocating smoke, and this potentially useful aspect of incendiaries was not overlooked in antiquity. Oh no, humans are very smart when it comes to creating weapons of death. Aeneas, Tactica, or the tactician, for example, advised the defenders of the city to make smoky fires and direct the smoke towards the besiegers who were trying to dig under the walls. The attackers also used smoke. The Chinese created poisonous smoke clouds by burning sulfur and arsenic to fumigate insects as early as 7th century BC, which may have led them to develop toxic gases for military use. Ancient Chinese texts contain hundreds of recipes for producing suffocating mists and clouds of smoke, and incendiary weapons manuals also give instructions for making poisonous smoke balls. In the 4th century BC, Rashashastra gave formulas for creating burning powders, the vapors of which, it was believed, drove enemies crazy, blinded, caused nausea, and sometimes death. Various smoke powders were prepared from the droppings of reptiles, animals, and birds, and mixed with real poisons and toxic substances. One deadly cloud was created by burning the bodies of poisonous snakes and the stinging insects, along with the seeds of poisonous plants and hot pepper. By the way, hot pepper was used in the New World in the 16th and 17th centuries. Caribbean and Brazilian Indians created an early form of pepper spray and used it against the Spanish conquistadores. Burning piles of crushed hot pepper seeds in India, the incombustible components of smoke powders were turpentine, wood resins, charcoal, and wax. However, despite its effectiveness, toxic smoke is extremely difficult to control and direct, so it was most effective when used in confined spaces such as tunnels. Back in the 4th century BC, defenders of fortresses in China burned poisonous substances and plants, such as the mustard seeds, in furnaces connected by pipes with cowhide furs to pump poisonous gases into the tunnels dug by the enemy. In western Greece, in 189 BC, during the long Roman siege of Ambracia, the defenders of the city invented a smoke machine to repel Roman attempts to tunnel under the city walls. The Ambracites made a huge vessel, equal in size to the tunnel, drilled a hole in the bottom and insert an iron tube. After stuffing a giant pot with layers of thin chicken feathers, it is known that the burning feathers create unpleasant smoke and smoldering coals. They directed the end of the vessel towards the attackers and attached the bellows to an iron pipe at the other end. With the help of bellows, the Amalekites filled the tunnel with clouds of acrid smoke, forcing the gasping Romans to hurry to the surface. In China, lime dust was used as tear gas to suppress riots. For example, in 178 AD, an armed peasant uprising was suppressed by harnessed lime chariots equipped with bellows for blowing fine lime dust in the wind. Obviously, the recoil from such wind-blown weapons was a significant problem. Those who used poisonous powders and smoke had to be aware of unpredictable gusts of winds. Kautilya was well aware of the danger and, speaking about poisonous fumes, warned that soldiers, before using chemical aerosols, should protect their eyes with protective ointments. A little later, the ancient strategists came up with the idea of combining chemicals. A treatise was often attributed to Julius Africaner, a philosopher born 170 AD, mentions a recipe for a paste into which sulfur, salt, resin, charcoal, asphalt, and quicklime are converted, and then this composition is tightly sealed in a bronze box protected from moisture and heat. In the evening, the resulting paste had to be surreptitiously smeared on enemy siege engines. At dawn, it was supposed to catch fire, igniting from heavy dew or light fog. Perhaps a paste like the one attributed to Julius Africaner could have been used by Medea to turn Princess Glauca's dress into a murder weapon. By the 1st century AD, Roman authors familiar with the magic tricks of self-igniting things and the destructive properties of oil began to reflect on the formula of Medea. In his version of the legend of Medea, the Stoic philosopher Seneca named sulfur as one of the components of the ignited Glauca's dress. He also referred to Medea's knowledge of natural oil wells in Asia Minor. Meanwhile, Pliny and Plutarch came to the conclusion that oil was probably one of the secret ingredients of Medea. These assumptions seem logical because Medea came from Colchis, a region between the Black and Caspian Sea, known for rich oil deposits, where burning gas wells were worshipped in the 6th century BC. Greek fire became a new terrible weapon after the discovery of oil by the ancient military. The origin of the Greek fire is connected with the fable. According to one legend, an angel whispered his formula to Constantine the Great, the first Christian emperor in 300 AD. But the Greek fire did not suddenly burst out on the stage out of nowhere. Centuries of observations, discoveries, and experiments with combustible sulfur, quicklime, and oil in formulas known by various names such as liquid fire, artificial or cooked fire, sea fire, wildfire, flying fire, and so on, eventually led to the invention of an incendiary device, which the Crusaders they gave the name to it as Greek fire in the 1200s. Although oil and its derivatives have been weapons since Assyrian times, in fact, Greek fire became a system for destroying ships in naval battles. The weapons consisted of advanced chemical ammunition and an ingenious delivery system, boilers, siphons, pipes, and pumps. The technology of pumping distilled oil under pressure through bronze pipes designed for ships was developed by a brilliant ancient engineer named Kallinikos. Fleeing from the Muslim occupation of Syria, he found refuge in Constantinople around 668 AD and told the Byzantines about his invention. Greek fire was first used to break the 7-year siege of Constantinople by Muslim fleet in 673 AD, and it saved the city from the Muslim fleet again in 718 AD. The Kallinikos formula and the delivery system are lost to modern science, and the historians and chemists trying to reconstruct how the device worked disagree about the exact composition of ammunition and the design of the system. The Greek fire burned in the water and possibly was lit by water, stuck to the victims. In addition to distilled oil, the ingredients could include the thickeners such as resin or wax, quicklime, sulfur, turpentine, and saltpeter. The exact formula matters less than the amazing feed system, which was able to shoot liquid fire from rotating nozzles installed on small vessels without the use of modern thermometers, safety valves, and pressure gauges. Since the 7th century, the Byzantines and the Arabs have developed variations of Greek fire, which resembled napalm in the sense that it clung to everything it touched, instantly igniting any organic material, the hull of a ship, oars, sails, rigging, crew, and clothing. Nothing was invulnerable, and even a jump into the sea could not extinguish the flames. The weapon made the enemies tremble with terror and start a desperate flight. Greek fire was the main weapon of its time, and the horror that it instilled in contemporaries is comparable to modern fear of the atomic or nuclear bomb. In 1139, the Second Lateran Council, following Western ideas of chivalry and noble warfare, ruled that Greek fire or similar burning weapons were too deadly to be used in Europe. The decision of the Council has been respected for centuries, but this issue may have remained controversial since the formula of Greek fire was apparently lost by the 13th century. The first precursors of Greek fire, so vividly described in the ancient Greek myth of Medea and Glaucus, and then tested in real battles during the Roman Empire, were the most terrible and formidable weapons of their time. There was no adequate countermeasure, no way to counter this infernal weapon. Neither extraordinary valor nor bronze armor could save the soldier, engulfed by cascades of corrosive flames that burned both the metal of the weapon and the flesh of the warrior. Yes, humans know how to invent weapons, including biological ones and other horrible types of weapons. So we spoke about the chemical ones today. Unfortunately, there are other kinds too, and they become ever more improved. So that is what I wanted to let you know too. If you like my research, please support it through the there are links in the description to this video, and I hope you will subscribe to my channel and tell others about it. Thank you for your attention. We'll bring you more videos soon.